Okay, so today I will be talking about different type of probabilities, and I will also introduce you certain formulas that are used commonly in studying probabilities. If you haven't watched my two last videos about probability, I will strongly suggest to do so. In that case, you will have a better understanding of the new subject, new formulas, and also about the probability. So today I will be talking about the probability called marginal probability. So what is the marginal probability? So probability of a single event occurring independent of other events. So that's what we call the marginal probability. Let's say we have a sample space of natural numbers from 1 till 9, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And so we have three different events. We have event A. Let's say event A has natural numbers like 1, 2, 3, and 4. Then we have the event B, which includes, let's say, another 6, 7, and 8. Then we have our event C, which includes 1, 7, let's say 8, and 9. So random selected natural numbers. So I want to know what is, so let's say, so given the sample space of this, what is the probability of event A happening? So what we are interested to find is that we have to find the PA. Okay, this is our point of interest happening. So this is the perfect example of the marginal probability. Why? Because we test the probability of a single event happening. So to do so, we have to get the successful number of event A divided total outcomes. Okay, total outcomes, meaning that in our case, for the PA, let's have a look again. We have a number of event here is a 4, and total number of the sample space, it's a 9. So there's 9 different elements. So it means we have to divide 4, the total number of outcomes, which is 9. So basically, this is our probability of the event A happening. So how it's gonna be for the, let's say, event B? What's the probability of event B happening? So in that case, when we look at the event B, we have only 3 elements here, 3 possibility of event happening. And the total, again, is going to be 9. So 3 divided 9, it's 1 divided 3. What we get around 0.33 or 33, let's say 0.3%. There's a 33.3 chance of event B occurring. So what is gonna be for the event, let's say C? So for that, again, we're gonna count number of events in the C. What we have here is only 4. So it's gonna be 4 divided 9. Again, we get 4 repeated. Rounding up, let's say we have 44.4%. So again, how we interpret the result, we have 44.4% of chance of event C happening. In the probability, you will often come across with a different sign. One of them is a sign like this, like U-shaped sign, which stands for the union. And we have another sign like this, what it stands for the intersection. Okay, you will see why I'm talking about this. Let's say we want to find the A union B. Okay, what does it give us? So here idea is that we have to combine the element that's in A and in the B. So that will give us, because if you look at again here on the top, the elements in the A, so we have 1, 2, 3, 4, and in the B we have 6, 7, 8. So actually it will give us 1, 2, 3, 4, then in the B 6, 7, 8. So this is the result of A union with the B. Okay, what about the B union with the C? So what are we going to get here? So again, so we know the elements from the B, it's a 6, 7, 8. Here we don't repeat the element twice. So it means that we have a 6, 7, 8 and 7, 8 repeated, so it will be 1, 6, 7, 8 and 9. Okay, we don't write it twice if it's repeated. So 1, 6, 7, 8 and 9. Okay, so this is our result of the B union with the C. So again, let's have a look now. What about the intersection of the B with the C? What are we going to get here? So now we have to look at the common values. What are the common values that are repeated with the B and the C? So we see that the common elements, it's gonna be the 7 and 8. So it's gonna be 7 and the 8, the common elements, which gives us the B intersect with the A. So what about the A intersect with the B? So we know that in the A we have 1, 2, 3, 4, and the B is 6, 7, 8. So there's no common element. So it's gonna be none, like there's nothing. Okay, there's nothing. And here it gets interesting. Since we said that in the A we have the elements 1, 2, 3, and 4. Okay, and in the B we have the elements which is 6, 7, 8. So we said that there is no common element. That's why what we call in probability, these are the mutually exclusive. Okay, so mutually exclusive. Oh wait, I did a mistake. So these are the mutually exclusive. So for short, we're gonna write it as a ME for now. Okay, so now we will look at another probability type, what we call the union probability. Okay, what's the union probability? Here we are talking, so we have either event A or event B occurring, or both event A and B happening. Okay, so let's say we want to find out the probability event A or B happening. How do we approach this? So to do so, first let's see, we said that A, I just checked something. Okay, so A union B gave us the following elements. Okay, 1, 2, 3, 4, 6, 7, and 8. So we have seven possible outcomes out of 9. Okay, and so this actually, the probability of event A or B happening is actually equal to the probability of event A union with B. Okay, I will show you why. Because here what we look, again, the P, A or B, we get again equal to A union B. Okay, A union B, these are our results that we get. So how many element does it contain? So we have seven possible outcomes here. Okay, so 7 possible outcomes out of 9, it means the 7 divided 9, which gives us 0.77 repeated. So to round it up, we get the 70.7%. So there's a 70.7% of chance of probability of event A or B happening. So to calculate the union probability, the real formula is that one. Okay, the P A union with the B equal to PA, probability of event A, plus probability of event B happening, and we have to deduct probability event A and the B. Okay, so then you can start questioning, okay, why in that case earlier we didn't we haven't done the P minus A and B, we only kept that part which stands for this. The thing is that earlier I spoke about the mutually exclusive, which was the case for the A and B. There's no common elements included in both. So then it means that the P, A and B in our case, it's equal to 0. Okay, so standing from that, we can say that then probability event A or B happening, it's gonna be simply probability event A happening plus probability of event B happening. Since it's a 0, we don't take it into account, so it gives us that one. Okay, so these are our results that we get. Actually, for divided 9, this is the probability of event A because it only includes the 4 elements. And the second, the probability of event B happening, it's a 3 divided 9, so it's actually, you get a 7 divided 9, what was the case here that we have seen earlier. The probability, the union of the P, A with the B was like 7 elements included here, so 7 divided 9. So it's important to understand this formula, how it's derived, and where, how we can use a shorter one instead of the including that one as well. So I want to also to show it visually, how does it look like the intersection event A and B for the mutually exclusive. So we said that let's have a Venn diagram. So this is our, let's say, event A, which includes 1, 2, 3, 4, and here we're gonna draw up our another circle with the elements of 6, 7, 8. So we said that these are the so they don't overlap, so these are the mutually exclusive. Okay, and what about the B and C? So for B and C, so let's say it's our B and this one our C. Inside the B, so we say the B contains these are elements 6, 7, and 8. So C was like 1, 7, 8, and 9. So it means that when we draw up here, so we will have a 6 here. So 7 and 8 is gonna be in the middle, they overlap, and here we will have the 1 and the 9. Okay, so it's simple as that. Okay, so last time we discussed the probability of P, like P, A, or B. It means probability of event A or event B happening, which equals to probability of event A union with a B. And this one is also at the same time equal to the probability of event A plus probability of event B minus probability of event A and B. If you remember, we said that since event A and B are mutually exclusive, here you see A has a 1, 2, 3, 4, and B has a 6, 7, 8. There is no like overlapping parts, there is no common elements, numbers repeated. So this we call mutually exclusive. So in that case, it means that probability of event A and B equals to 0. So it means that, so this formula becomes as following. So it means B, a probability of event A or B equals to P of event A union with the B, and this simply becomes probability of event A plus event B, since this one is going to be 0 here. And in this part, I want to concentrate now calculating the probability of event B or C. So just to look at the elements of B and C. So B we have 6, 7, 8, and C we have 1, 7, 8, and 9, and 7 and 8 are repeated in this both probabilities. This is overlapping part. So it means that B and C are not mutually exclusive, which was the case for the A and B. So meaning that to calculate the probability of event B or event C happening, we will do of probability of event B plus probability of event C and minus probability of event B and C. So what does this mean? So probability of event B, we have only 3 elements here, and we have 4 is here. So it means in our case it's gonna be, the probability of event B is gonna be 3 divided to 9, because in total we have 9 numbers in our example. So for the second it has a 4, so it means 4 divided 9, and for the overlapping part we see there's only 2 here, so it's 2 elements. It's gonna be then the minus 2 divided 9. So 3 plus 4 minus 2, it gives us 5 divided 9. So let's calculate it with another way. So we can write this expression, probability B or C occurring with a B union with a C. If we start figuring this out, so it means so the P union with C, so we have a sample space. It means that, okay, so B union C, it gives us 1, 6, 7, 8, and 9. And we can see that this represents 5 possible outcomes out of a total 9. So it means 5 over 9. So you see the result are the same here. So the reason why this part of equation is here, because we don't want to calculate the 7 and 8 twice, because these are already repeated in the intersection part. So this part of the equation ideally helps us to correct, not to calculate twice. So it means that we are taking away 2 elements that are in this intersection part, so overlapping parts that you said. So if the events are mutually exclusive, so it doesn't matter, because this part becomes 0, as we have seen earlier with the case of P, A, and B earlier. So